Hello, everyone, and thank you very much for joining us today for Jetro Chicago's Jconnect webinar series. My name is Kevin Kalb, Business Development Specialist from Jetro Chicago. I will be moderating today's webinar. Our topic for today is robotics, AI, and software, featuring Ready Robotics from Columbus, Ohio, and Apex AI and SMP Robotics from the San Francisco Bay Area. We would like to welcome you if this is your first time attending the Jconnect webinar. Our focus is to help connect innovative North American startups to Japanese affiliated companies doing business here in North America. Most importantly, we hope to facilitate new business relationships between the startup presenters and Japanese companies. Likewise, the webinar series aims to improve the productivity of Japanese companies and to help accelerate their open innovation strategies. Jetro Chicago, we recently added a landing page for the Jconnect webinar series on our Jetro USA web page. You can find dates and information on upcoming industry topics, as well as recordings of our previous webinars. Today's topic is robotics, AI, and software, which is going to cover applications of artificial intelligence and software platforms to industrial robotics and autonomous systems. Robotics and automation have bucked the economic trends and shown growth during the pandemic, with imports of industrial robots into the US growing at 5% this year, and exports in the second quarter growing 13% from Japan, this according to the Financial Times. This is creating a strategic boost in digital factory technologies being implemented, as automation is now being viewed as a competitive advantage instead of just a simple cost reduction. Likewise, autonomous solutions for warehouse robots, security robots, delivery robots, and more are seeing an increase in demand. It is expected that many of these technological and digital innovations being applied to robotics and autonomous systems will likely remain in place after the global economy recovers from this pandemic. I will let our three speakers give their guidance and expertise on robotics. So I would like to introduce our first speaker, Dr. Kjell Gering, co-founder and chief technology officer of Ready Robotics in Columbus, Ohio. Kjell has been working in the robotics space for more than 10 years, focusing on the design and usability of a wide variety of robots, including systems for space exploration, deep mining, surgery, and industrial manufacturing. While obtaining his PhD from Johns Hopkins University, Kjell worked specifically on the challenge of making industrial robots more flexible and easy to use. The result was his award-winning Forge operating system and easy-to-use programming interface for industrial robots. Kjell spun this technology out into Ready Robotics, an industrial robotics startup he co-founded in 2016. His work has been featured in the Wall Street Journal, Forbes, and Ready's products have been called the Swiss Army knife of robots by Inc. magazine. So Kjell, if you want to go ahead and share your screen.
Okay. Well, thank you so much again for being able to provide this opportunity to speak with all of you. I'm honored to be here. Again, my name is Kjell Gering, and I'm the Chief Technology Officer and co-founder of Ready Robotics. And really what I'm here to talk to you about is how we can use technology to make robotic systems easier to use. And by doing so, allow workers in industrial manufacturing to be much more rapidly upskilled to be able to use these systems as the tools that they are. We think that this really has the opportunity to allow companies to be more empowered to deploy more automation faster because, as we all know, we need as much automation as we can get our hands on right now. So what we do, so let's first talk about why robots aren't more widespread. We see that there are a lot of different technologies out there in the world. Robots have been around since the 1960s, and which is interesting because computers sort of got the same start at the same time, and we see how computers have changed the world, but we haven't really seen robots permeate our everyday lives and completely transform manufacturing the way that computers have transformed just about everything else. And we think at Ready that a key reason for that is the fact that computers went through a phase where they became very usable. They became tools that anyone can just pick up and use without specific training. And we're hoping to do the same for robotics. So the fact of the matter is robots are too hard to program. It takes a lot of in-depth knowledge, especially for someone without a huge background in technology, as many of the workers in manufacturing tend to be. And that means that the upskilling necessary to enable them to use robots is significant. And this has been recognized as a huge barrier to deploying automation. McKinsey, had an article a couple of years ago where they said specifically that difficulty in programming and the fact that there was no common platform, that you couldn't learn one type of way to program a robot and then run that on any robot, was really a huge barrier to a lot of manufacturers. And we see this every day when we look at the variety of robots that are out there, and each has their own programming language, their own operating system. You have to go to separate training courses. It's not like me buying a laptop where I can just buy a laptop from whichever vendor I care to, and I can use an operating system that is the same across any one, and I can just use it as a user, right? So that's really what we're trying to enable. We don't want to see a world where there is more robot programmers. We want to see a world where everyone can be a robot programmer, where any worker is able to very quickly, as easy as they can use a smartphone, pick it up and use it, to be able to use a robot in an industrial setting, just like how there are many tools that we use in an industrial setting that workers can just use and find value in immediately. And we think the barrier to that happening in robotics is far too high. So how have we solved that problem? Well, what we have built at Ready is called ForgeOS, and it is an operating system and a no-code programming interface working on a modern touchscreen teach pendant that allows anyone, and I mean anyone, to program a robot, honestly, in just a few minutes, and then be very competent at programming that robot in a few hours or days. It completely upends the traditional paradigm where you have to go to weeks of training to be able to program an industrial robot. Instead, we're talking hours. And once you learn how to use that very easy programming interface, you can see it depicted here in this picture. It's just a very simple flowchart with building blocks. Each building block represents something that the robot can do, whether it's move to a position, open and close its gripper, etc. Once you learn that programming interface, then you now can take that knowledge to any robot that ForgeOS runs on, which is a growing variety, as I'll talk about, and you can now use that same programming skill, right? You don't have to learn something new going from a Fanuc to a Yaskawa to a Nachi. You can just learn one thing and be able to use all of those different systems. The other thing that you can do with ForgeOS is control any peripheral. So as we all know, anyone who's familiar with robotics, the robot is a cool tool, but it needs a lot of other hardware and devices in order to actually practically do a task. And ForgeOS allows you to control all of the other peripheral sensors, pneumatics that are necessary to actually get the robot to do its job. So not only does ForgeOS enable you to pick the right robot for the right application, there are many robot brands out there. They each have their specific capabilities. Some are better at some applications than others. And it's really been the case where companies have had to pick and choose based on their investment in training for a specific brand. They haven't been able to look at the latest technology from a different brand because they're already so invested in the current brand that they've learned how to use. So this is just a smattering of the robot companies that are out there, and ForgeOS's ultimate goal is to support all of them, a large number of these, by the end of the year. The other thing that it allows you to do is pick the right peripherals for each application. The effort it takes to actually use a peripheral with a robot and program whatever driver is necessary for that robot is a lot of effort on top of just programming the robot. So ForgeOS makes it easy to pick not only the right robot for the job, but the right tool for the job. And this is just some of the many peripherals that we support with our software. So where have we seen companies succeed with this technology? Well, in a lot of different places, from small manufacturers all the way up to large enterprises. in a variety of different industries: aerospace, automotive, boat, trucking, medical devices, etc. So just to give you a few of those, one of our larger customers, Stanley Black & Decker, they were able to deploy a huge number of robots that they were not able to deploy previously because they didn't have the skilled expertise in-house in order to deploy that. That easy programming really let them upskill their people rapidly and program hundreds of tasks since they've started using our software. This also eliminates a lot of bottlenecks because they might have a process where they want to put a robot in place and they can't, but they're losing money as they are unable to do that because they don't have enough capacity and they need automation in place to get that capacity up. And then any kind of reprogramming that is necessary if this line were to go down, which happens, it's manufacturing, it takes a long time if you don't have people skilled at working with this hardware. The fact that you make working with the robot easier means that fixing any issue becomes much, much faster. We also saw a lot of, to sort of go to the other end of the spectrum, Alley Cat Scientific is a very small manufacturer, but they're very important in that they're one of the leaders in flow controllers for ventilators, and which obviously became a huge importance in March with the rise of COVID. They were in a similar position where they were bottlenecked. They were trying to create these flow controllers. They really needed something to unlock the process for them, to unlock that bottleneck. And with our software, they were able to deploy a robot in 3 days, which if any of you have any experience in robotics, we're talking weeks to months for most robotic systems. So 3 days, they were able to deploy the robot and have it running. They were able to run it lights out, meaning overnight without anyone there at the factory to monitor it, which is another significant milestone, in 10 days. And they did this all on their own with just our software and our documentation. That's it. And because of that, because they were able to boost that output so much, they paid off that system. They got a return on that investment in 30 days, which is pretty incredible. We also have had luck in the transportation and heavy machinery space. Harmonic Machine is a great example of this. Again, deploying with their existing staff, right? They don't have to bring in an outside integrator. They're doing this themselves because it's so easy. They've been able to hire more people and expand their production because of the automation sort of took all of the effort that people were doing on doing manual tasks and let them refocus that talent to other areas of their business because this easy to use automation was in place. And also get insane, really impressive utilization of their equipment with this automation. Surtech is another great example of this. Surtech does a lot of changeover because they have a sort of a high mix, low volume production line. And they are able to change over a part to a different component with our software, the robot side of our software, in 60 seconds, which means that anytime they switch between parts, they're not spending hours setting up the robot, reprogramming it, or worse, bringing in an outside entity to reprogram the robot when they have to do changeover. That's something that's very common as well. So all of that goes away because it's easy enough that the people there at the factory are able to do this. So just overall, ForgeOS customers are able to dramatically reduce the cost of their automation, both the upfront cost of programming it and the ongoing cost of supporting it. They can retain their top talent because now the people that usually are doing very high value tasks, but end up spending a lot of their time doing low value tasks. You know, you'll have a machinist who programs the machine, very high value, but then ends up putting pieces of metal into the machine all day long, very low value. Instead, now they have an automation system doing those important, but to a person, low value tasks. And now that person is freed up to do nothing but high value tasks elsewhere. Now he can go program 5 or 10 of those machines instead of just one because he now has the time to do so. And productivity, right? You're able to run a lights out shift. We know that there's a skills gap in manufacturing. It's very hard to find talented people that are able to run a second and third shift. And a robot is able to do that. And that robot being programmed by the domain experts now, by the people on the floor who know the most about the process, are well equipped to now do that process reliably overnight. So let's just talk about reduced costs, because there are a lot of hidden costs in robotics. We see that there's a good deal of troubleshooting and reprogramming that has to be done. The initial programming is costly, and all of this adds up to a lot of costs when you're implementing an automation system, which means a lot of companies end up not moving forward with automation. They just say, look, it's not worth it. We can do it with our people, and I can find some temp worker to do it, and it's not worth it, right? So they end up not moving forward with automation. We reduce that overall by more than 30%, all of it. The hardware costs, because now you can spend more money focused on hardware that better fits your tasks. The programming costs go down. All of that follow-on costs of troubleshooting and reprogramming go down because you're using your own people with this very easy to use software. So again, top talent. Being able to attract talent with that are willing to come into the manufacturing space and work on these amazing projects. They can't come in after getting a really fancy college degree and then look at something that looks like I'm programming a robot from the 80s, right? They need something that is modern to retain them, or else they're going to move to other industries. And that's really the focus of Ready Academy, is preparing people for entering this space and empowering them with the tools to actually learn how to program these robots. So Ready Academy is an online resource where you can learn about how to use our software. It's completely free. We're happy to provide it access to any of you who are interested in it. But the idea is you go online, you learn about these classes and learn about how to program a robot with Forge OS, and now are empowered with that knowledge. You know how to put an industrial robot to work, even if you weren't familiar with robotics or you weren't in the manufacturing space. And now you could be interested in joining that space. And that is great for manufacturers because that is pulling talent into the market that is now capable of working with industrial robots and industrial automation. It also allows, as I said, operators who are already at these manufacturers to very easily upskill, right? And right now for free, because they can go online, take these courses. It's roughly 40 hours of content that covers all aspects of the robot and how to use it for real tasks. For real, the task we have right now is machine tending, but it's everything, including how to fixture your parts, how to put parts into the machine, work holding grippers, all of that stuff that you need to actually do the task. It just allows you in general to improve the productivity of your people. And what we're seeing is people are spending too much time troubleshooting problems and not enough time improving operations. Very talented people. And by making this technology easier, it means more people are able to use it. It's more accessible. And overall, we see that creating this shift in manufacturing where value is being created by people more and more, where we spend a huge amount of time right now programming, troubleshooting, and very little time identifying improvements, being agile, thinking in a Kaizen manner where we want to improve, but we're not able to because we're troubleshooting. And we see that shifting to, because the software is so much easier to use, you're spending a majority of your time doing the value-adding things, identifying operations, improving efficiency, creating new processes, and less time programming robots and fixing them, right? So that's very much what we're about at Ready. We think that the power of usability and the focus of a piece of software that anyone can very easily use that then works on any robot has a huge transformative power in the industry because it really unlocks people's ability to use and get value from industrial robots. So thank you so much for the opportunity to speak with you. I look forward to your questions. Arigato gozaimashita, and thank you.
Thank you, Kel. Great presentation. I'm going to go ahead and start to introduce our next speaker, Sanjay Krishnan, VP of Products at Apex AI. Sanjay oversees product strategy and key initiatives to accelerate industry-wide adoption of a modern modular stack of algorithms and software framework for self-driving cars, drones, and robots. Over 2 decades in the hardware and software industries, he has developed, managed, and deployed cutting-edge technologies for consumer and enterprise users at leading companies like Cadence, Skyworks, and Maxim. He has served on the advisory board at Geomagical Labs, a pioneer in machine learning techniques and computer vision, and is a frequent speaker at events on the commercial future of advanced technologies. And thank you for joining us here at our Jconnect webinar today, Sanjay.
Okay, very good. Pleased to make the connection, and thank you for the opportunity to present Apex AI to this audience. Hello to everybody, and I'm here to give you an introduction to Apex AI and how we enable software development for autonomous vehicles. So jumping right in, Apex AI is a software company founded about a little under 4 years ago, based in California. And our vision is to enable safe and reliable autonomous systems. Autonomous systems could be robots, but also extends to other types of autonomous systems that are autonomous vehicles, delivery robots, and even drones. Our expertise is in software, modern C++ software for real-time embedded systems. And specifically, what we're focused on is software that is safe and safety certified for operating in a safety critical environment that often includes humans, where safety certification is important and built in a modern C++ way. And that's something that hasn't really been done in the industry, and it's something that we have actually brought. In terms of products, there are three that our customers are in various stages of evaluating or prototyping or deploying. They are Apex OS, Apex Autonomy, and Marv Automotive. I'll spend the bulk of the time here in this talk on Apex OS. It's the first product that is the most mature in our product portfolio, and it is a ROS compatible, safety certified automotive SDK that can be used for developing autonomous vehicles. And as a startup, our focus has been on the automobile industry, in enabling self-driving cars to reach level 4 autonomy, and doing that using modern software practices. So like I was saying, the Apex AI core expertise is at the intersection of automotive and robotics in software that is safety and safety certifiable. A little background about our timeline as a company. We're, like I mentioned, a little under 4 years old. We were founded here in California with investment from some of the well-known venture capitalists, but also of interest to this audience would be some of the automotive industry investments that we have got. If I just zoom in, you'll be able to see that we have got strategic investment from Airbus, Toyota, Volvo, Hella Ventures, and InMotion, which is actually the venture arm of Jaguar Land Rover. We've released our first product, first version, commercial version of our product in January of 2020, Apex OS, and we are moving ahead and should complete the automotive qualification of this software by the end of this year. Our co-founders are both industry veterans with PhDs and deep expertise in the areas of robotics and autonomous systems development, and have worked at many companies that are well known, including Bosch, for which they were overlapped in several years. We are based here in California, but we have a significant presence also in Germany, and we have partner companies around the world that we work with in some capacity, one capacity or another. As I mentioned earlier, our application field is not just robotics and not just autonomous driving, but really any kind of system that involves software development and that involves operating in an area that requires safety criticality or mission criticality of some sort. And that's the reason why we have developed Apex OS, a derivative of ROS that I mentioned, and I'll go into that in a second. And it can be Apex OS really is a ROS-like abstraction layer, which enables development at any level of automation and in any sort of autonomous application, but across all stages from prototype to deployment, because as I mentioned, it is deployment ready, being production grade and safety certified, and really works with almost any sensor, driver, or software component that's available out there. And this is also partly true because coming from open source, there is a huge ecosystem and community of development that has already happened in terms of being interoperable with various other types of technologies out there. Let me spend a few minutes just going a little bit deeper into Apex OS. As I mentioned, a safety certified SDK that we deliver, which is based on ROS2. When I say based on ROS2, it is API compatible with ROS2, and ROS2 being the latest and greatest version of ROS, the open source robot operating system, and it is available either as an out of the box plug-in replacement for ROS2, or in fact for some of our customers, something that can be integrated into their software systems that enable customized or semi-customized application development environments that they want to enable. I want to spend just a few minutes for those who are not as familiar with ROS in terms of what actually it is and where we come from. If you look at the full stack of technologies on the left-hand side that are actually used for developing an autonomous system, you'll actually see that there is a very large, specifically for autonomous vehicles, a very large set of onboard and offboard software, including components that are used in the cloud or methodologies that are actually needed before you can actually tune and deploy something that is safety critical in real-time environments on the road. And this includes hardware components, software components, onboard and offboard components, and a lot of testing and methodology to prove that your system is actually safety certified. Safety certifiable is what we like to say before you can actually go through the process to obtain the certificate. If you focus on the couple of layers in the onboard software that are critical to ensuring this safety, you'll see framework and operating system as two different layers. The framework is actually a set of common methods in which you interface with the operating system and the hardware underneath. And ROS is an example of a framework layer. Now, often it's also called middleware. We use the term framework software for what ROS actually enables. ROS is called a robot operating system, and so the name OS is also stuck with it. But in reality, what we like to refer to it as a framework software. ROS1 running on top of Linux is the open source that started this whole robotics revolution of being able to make robotics much more easy to develop, prototype, and tune. It's been around for over 10 years. A couple of years ago, ROS2 started, which was basically a rewrite of ROS, which improved code quality, made it smaller, more optimized, and standardized on the middleware, and also included better testing and documentation. We, Apex AI, take ROS2 and we make the real-time, memory static, robust, production-grade version of it, and that is Apex OS. So Apex OS is API compatible with ROS2, and Apex OS is actually deployable in a system that requires real-time deterministic behavior. And for that reason, we expect that many of our customers will run Apex OS on top of not the open source Linux, but on top of something that is certifiably real-time and therefore safety certifiable. We are going through the safety certification process, as I mentioned, and when we complete that by end of this year, we will have a product which is separately licensed, and that will be called Apex OS Certified, or Apex OS Cert for short. And we expect that that will be used by our customers running alongside other safety certified software, like, for example, QNX for safety is an example of such a software. So this is just two layers in the stack that I'm showing, but the important distinction is between open source and proprietary. So what you see in ROS2 running on Linux is actually open source and free to use and has a large and very large community of users, whereas the proprietary software comes from Apex AI, and it is called Apex OS. Just to drive the point home, the software that we provide is Apex OS, and it includes the ROS2 compatible um, layer, and it does not include other layers like the embedded real-time OS. What is shown in this picture is just for completeness sake to show what a full stack might look like when you're actually running onboard software in conjunction with other software. So completing this, I wanted to tell you a little bit about Apex Autonomy. Apex Autonomy is the software that started out as a reference system that we built on top of Apex OS. So going back to this stack diagram, if you look one more layer on top, what you will see is that for a fully autonomous system, you actually need a fairly significant amount of algorithmic software development to integrate with all the sensor inputs that are happening in an autonomous vehicle, and to determine what the environment actually is, to make decisions based on those environments, and to actually control the vehicle. And all of this has to happen in real time, right? And so there is a fairly well-regarded open source effort here, and it's called AutoWare. And AutoWare has been around for a few years. The version that runs on top of ROS1 is called AutoWare AI. Also, over a year ago, there was a new effort to bring this also, just like ROS1 to ROS2, bring the same ideas of improved code quality, um, better testing, better optimization, essentially redesigned algorithmic layer, and that's what is called AutoWare Auto. There's been a lot of new interesting developments in AutoWare Auto, which I will go into in just a couple of minutes. But what's of note here is AutoWare.auto is an algorithmic stack written on top of ROS2 and is fully open source. When I say open source, by the way, it's Apache 2 license, which is a permissive license. It allows any company to take it and to deploy it in commercial products. So a very easy application to enable. We take AutoWare Auto and we have made a production grade version of it, and it is called Apex Autonomy. Apex Autonomy is the proprietary software layer that consists of algorithmic building blocks, specifically built on top of the Apex OS. So Apex OS, which provides the framework layer, which is safety certified, can run Apex Autonomy, the safety certified version of algorithms running on top of it. And just like this diagram shows, this is actually able to be deployed because we have designed it from the ground up to be deployable in a safety certified environment. And when we do complete the safety certification of this thing, we actually will call it a different product, and that will be called Apex OS.cert. I'm sorry, Apex Autonomy.cert. So let me move on to the next point here. I just wanted to show you a very quick demo video of the Apex Autonomy stack, and this is a LiDAR stack that is running in real time that you can see in this video. What you're seeing on the top right-hand corner is actually the what's in the camera view, and what you're seeing in the main part of this video is actually the real-time Apex Autonomy LiDAR stack, showing you the bounding boxes derived from the raw data. And this is actually running on the Apex Autonomy Apex OS stack. And you can see the output that we've recorded in this video. I mentioned to you something about open source. I wanted to show you something that is, I think, very interesting, which is autonomous valet parking. So AVP, which is the short form for autonomous valet parking, is something that has been in the news quite a bit because there have been some companies that have developed and deployed and showcased such a capability during in the recent last few months. Essentially, what it means is what you can imagine from a valet parking functionality. Drop off a car, it goes parks itself in a pre-designed spot. And when you're ready to pick it up, the car is available for you to come and pick up. This has actually recently, just as a couple of weeks ago, been demonstrated using full open source components that I just showed you, and with a number of contributors. Many of these companies that actually I have put on this slide here. Because it's all in open source, you can actually follow along what the development environment looks like, and what the various components are and how they've developed over time. And in fact, all the planning and execution has also happened in open source, with a lot of the milestones that have been contributed from different companies, and notably here, this companies spanning US, Europe, and Japan. AutoWare Auto, as a result of all this, as we feel, become a nice self-sustaining community with enough developer interest to go over to become um, a full-fledged autonomous development system that can support um, more than just this one particular use case. What's of note here is that it's all based on ROS2 and AutoWare Auto, defining a lot of common interfaces and common environments for the industry as a whole to take and build on top of. And we are hoping that there's a lot more contributions that are coming in that takes this beyond autonomous valet parking into applications such as cargo delivery and possibly even other things. A very short couple of videos that I wanted to show again on this thing. This video is, by the way, just a couple of weeks old, showing this car in simulation on the left-hand side, that you can actually look at the path planning algorithm, do its forward planning in terms of LiDAR-based scene recognition. And by the way, the mapping that you see of the parking lot that we actually demonstrated autonomous parking is all based on a 3D 3D point cloud that has been 3D pre-mapped onto this thing. So I want to switch quickly to the actual demo video that that we hadn't seen before. The video here that's actually showing the car that is running, that's following the same path planning algorithm. By the way, this car is outfitted, is from a software point of view, running the full open source software stack that I just showed you. The car itself belongs to Apex AI, and we've been using this car for a few demos such as this, and you can see the parking planner that was contributed by Embotech, the simulation contributed by LGSVL, many of the components of the LiDAR processing actually contributed by Apex AI, and there'll be a lot more detail on the Apex AI website and the AutoWare Auto website that tells you various other components of contribution that have already landed and are still continuing actually as we go into other areas of autonomous driving.
Just flip a coin. There.
All right, to wrap it up, I think my conclusion is that Apex OS enables a path to production based on open source, and we actually enable several different types of autonomous systems, several different types of applications, and a complete developer environment that includes not only the operating system, but all kinds of support that you expect from a professional development environment. Thank you.
Thank you so much, Sanjay. And I'm going to go ahead and start introducing our final speaker from S&P Robotics, Tal Turner. He's Vice President of Business Development and Partnerships. Tal brings a decade of outstanding experience in the autonomous security robotics field. In his recent roles, he's served as Global Business Development Leader of Nightingale Security, T-Mobile, Keynote Systems, Cotendo, which was sold to Akamai, and CEO of Tal Turner Consulting. He plans to speak with great pleasure about S&P Robotics and its advanced autonomous solution that is revolutionizing the security landscape. And Tal, if you'd like to go ahead and pull your screen up.
Sure. Thank you, Kevin. Very gracious. I'm going to have Phil Carlin, my partner here in Anaheim, California, support me because I'm on double conference calls at this point. But I will give the introduction and let Phil take over. S&P Robotics, gentlemen, is a 10-year-old company that is specialized in security perimeter security, logistics security, data center security, any type of, let's say, chemical or critical infrastructure, gentlemen, we specialize in. We're not really a startup. We've been around for a long time, and we use AI and robotics to basically supplement or support the security infrastructure. So the example that, before Phil starts in here, I can give you is that we're very good at supporting a security system, a security guard, a security video system, a security sensor system. And we're able to augment that, add to it another layer of robotics and AI that allows a company, let's say in Saudi Arabia, all the way to New Jersey, to be able to see things, have forward reconnaissance, and understand what they have in front of them, whether it's a breach of security, whether it's a someone trying to get into their truck yards, or whether it's even an animal trying to get in. All the above are capable with these robots. But I'll let Phil take over here. Phil, do you want to put your slides on here?
Okay. Thank you, everybody, for your time today. I'm Phil Carlin. I'm Vice President of AI Distribution here in Irvine, California. We are a authorized technology partner of SMP Robotics. We supply the sales, the support, integration, and logistics of SMP Robotics. What I'm going to do today is just keep things really simple, and I want to present the solution to the audience, and then we have a short video that can show as a product demonstration. But like Tal said, we are meeting with multiple organizations, high-level organizations that now have steering committees, and they are looking to improve process and streamline automation of security. The SMP Robotics, hands down, are the best security robots in the industry. They're fully autonomous. They are rugged. They can run and operate at high temperatures and cold temperatures. They can climb 45-degree mountains, like hills, and they can, for example, live at substations, electrical substations year-round because of the automated charging system capability. So I'll just kind of touch base a little bit about the robot and the capability. So the SMP robot is now a third generation. It's the S5-2. We also have an S3-2, which is designed specifically for substation and thermal inspections. There's also a number of different sensors that can be added to the robots. But going from the top down, it's got a 360 PTZ IR camera that rotates in 360 degrees. It's fully ONVIV compatible for all security operation centers. It has 6 HD cameras on board. It has a two-way microphone, which is a great feature. Like I mentioned earlier, it has an automated charging station. That capability sets it apart from most of the other autonomous robots you might see out there. The other robots tend to have to be either plugged in, or when they charge, they have to charge for a long period of time, where the SMP robotic can charge for about 2 hours and run from 8 to 12 hours. And once you add a second robot, you have a 24-hour continuous patrolling, usually in restricted areas, or it could be a an added solution at a gate, for example, at a big facility gate. Again, it's fully autonomous. It has human detection, artificial intelligence. It can have license plate recognition on it, and it has we do have restricted API, but if that's something that anybody needs, we have SDK and API available. And pretty much in a nutshell, this is what I consider the best security solution that is out there in the market today. We are working with existing security operations. So we're seeing customers are saving at least 50% or more based on security contracts. So they're realizing immediately a return on investment by adding security robotics into their security operations. That's pretty much the solution that what the S&P robot is and what it's about. And I think right now is probably a good time to show the short video we have so you can actually see the product demonstration.
What I want to talk today about is how technology and robotics is changing the security landscape. So 30 years ago, we saw the advancement of surveillance and security cameras. Today, we are seeing the next generation of technology for security is now here. So what does that mean? What it means is that the technology using security robotics is going to be essential for the success of any business here in the United States. After extensive research, our team identified that S&P Robotics clearly is the best solution provider for autonomous security robots, hands down, by delivering affordability, reliability, and dependability. So what does it mean for our customers? Well, it's very simple. We're going to offer an additional layer of security with better return on investment, improved security operations, and scalability. So how do you get started? What we're seeing with our existing customers is an immediate improvement in security operations with enhanced oversight and reduced operational expenses. So if you're a security provider that is experiencing challenges in the areas of guards calling out, no-shows, or any underperformance, you should connect with us to learn how to get started. Today we are seeing that our customers are saving over 50% or more by using autonomous security robots.
Phil, do you want to give some final comments?
I think that kind of summarizes it. So if anybody has any questions, they know anybody, immediately who's looking to learn any more information, here's our website. Here's our email address for more information. And we're also on Instagram. But no, I really appreciate everybody's time today, and we thank you, and we look forward to connecting with you or hearing from you with any further questions or inquiries.
Okay, thank you, Phil. So thank you guys for your presentation, S&P Robotics. As we get ready to move along to our panel session with the questions and answers that have come in during the presentation, I'd like to let you know that we are planning to have upcoming Jconnect webinars on the topics of supply chain automation, as well as future connected worker, likely in November and December. So please stay tuned. And as I mentioned previously, please check out the new Jconnect landing page for further registration details and event information. So Jeff of Chicago is going to organize another webinar on Thursday, November 12th, early evening US time, morning Japan time. The webinar is focused on startup investment during the pandemic and outside the Silicon Valley ecosystem. As a speaker, we will have Manas Mehandru, COO of MHub, which is the largest Monozukuri incubator here in Chicago. We also welcome Jeff Erickson, Director of Business Development at Carta. Carta is a Palo Alto-based unicorn company that specializes in capitalization, table management, and valuation software. Details can be found in our follow-up email tomorrow, so please check it out. I'll go ahead and start off with a question here. How are your companies seeing the growth trends for your technologies in this global pandemic slowdown? Kel, do you want to go ahead and start off? How is business here during the pandemic?
Absolutely. I'll turn that over to Luke, but just briefly, we're seeing a huge demand for automation in manufacturing because of global events. It's undeniable. And that really, from our business perspective, we're trying to build technology that makes it easier to deploy these systems. And there are a lot of companies out there that are really frustrated with the technology that they have right now, and that because of these global events want to deploy more automation. So we're seeing, a lot of demand.
And that a lot of these companies, they don't know what to do next. So our software and how we approach automation, not just with the technology, but with solutions for their people and internal processes. We found a lot of interest in that, particularly with the executives who are looking at the deployment of automation. And then kind of, as Kel talked about one of the case studies with AlleyCat, people are really interested in deliveries that don't require and having engineers showing up at their shop or their manufacturing plant to install equipment. So being able to deploy automation that the workers themselves in-house can manage also gives a lot of benefit when it comes to resiliency and their ability to kind of weather the some of the restrictions that are being placed on them with having people enter their facilities.
Thank you, Luke. Sanjay, do you want to talk about how things are going during the pandemic for Apex?
Yeah, in terms of the pandemic, our focus market is really self-driving cars, and we're seeing a lot of long-term investment ongoing into that. And this industry for autonomous driving is really something that is still years out when it comes to deploying level 4 autonomous systems. And so we are actually not seeing a big impact as of today. Some of the R&D projects in the larger automotive companies are evaluating what their short-term goals are, and they're realigning some of their investments, and that's has a sort of a secondary effect on us. But we are mostly involved in longer-term R&D projects, and our customer base is continuing investing in that. So we're not seeing a short-term change one way or the other from the pandemic.
That's good. And S&P Robotics, I'm not sure if Tal or Philip want to maybe discuss. I'm sure you've had extra business.
Yeah, I could jump in and, well, as you can imagine, pre-COVID, there was a high interest. Post-COVID, it's just been unbelievable because when we're working in the physical security, well, we're in the autonomous security line of business, but in the physical security, all the people have been affected and some have been infected, which caused a lot of companies to be under pressure to add additional security. Well, as you know, an autonomous robot isn't affected by any of that. So, we are still working with security companies and security operations centers and people, but the demand has really taken an uptick in demand because of what we've seen recently. So yeah, by far, robots have come in at a great time to help companies, sustain and improve their security operations.
We had a question about the Forge OS. I'm not sure if Kel or Luke want to answer, but is Forge OS a front-end programming interface or an actual OS like ROS? Or how do you differentiate with a ROS, robotic operating system?
So yeah, so the way that we see ROS is very much that they've focused on creating a set of low-level libraries for robots. While our philosophy is a little bit different, we actually see a huge amount of value in the underlying robot and the software that's built on top of the underlying robot. Those control programs are very valuable because the company has spent a lot of effort making them for their specific hardware. And Forge OS communicates with that robot at a much higher level, at sort of a command and control level, which means that you actually get to, through Forge OS, utilize all of those built-in capabilities that are sort of the proprietary magic that makes those robots a compelling product. And so we actually sort of augment that existing capability rather than trying to get our hands down in the low-level hardware. On top of that, we also build out an SDK for Forge OS. And you can think of it very much like Android in that sense, where Forge OS is taking care of all of the hardware interfaces and everything and exposing those up as a very easy to use API layer that an app developer, and we call them app developers, can come along and build industrial applications on top of Forge OS. Because not only when we talk about being able to address the usability of robots, but there's also companies out there that are creating really amazing capabilities for robots, vision companies, companies working on artificial intelligence. And right now they have to do a huge amount of effort to build all those picks and shovels for that software so that they can get their product to market. So, you know, just like Android and iOS did for the phone industry and Windows did for the laptop and computer industry, we're seeing ourselves as that platform and marketplace for those developers. And that's something that ROS doesn't really do. It's more of just a set of libraries.
Okay, I have a question here for Sanjay now. I know you answered this maybe in the chat function, but just to share it with the audience. In your last AVP demonstration, I was curious about what kind of sensor feedback was needed to complete the series of action. Is it merely relying on the onboard sensors to find that spot? Or is there an instruction from an upper controller that tells where to park?
So, you know, the nice thing about the open source is you can actually find all the answers in AutoWare Auto. But specifically, I can tell you that in this case, the entire parking lot was pre-mapped with a 3D point cloud map, and the exact parking spot where the car went to and came from was predetermined for the demo purposes anyway. And the way the car actually localized itself in the environment was using LiDAR sensors and the perception and localization stack that is in AutoWare Auto.
Sanjay, do you also have the technology to control AGVs, automated guide vehicles?
So to control probably is not the right word, but yes, Apex OS can be used in autonomous ground vehicles or any sort of autonomous vehicles, definitely. When you say the control is a specific function, you know, is a part of the onboard stack, is the actual vehicle control, and it depends on what type of controls it has and what type of vehicle features that are actually there in the vehicle. And that is a question for probably not the OS layer of the stack, but the higher layer of the stack. But the short answer to the question is Apex OS for sure can be used in any sort of vehicle.
Thank you. And Phil, I believe that you're also outside of security robots as well. Just if you want to kind of touch on that. Are you?
So can you redefine the question for like SMP and like how?
The question was basically on automated guide vehicles, but if I recall that you guys are doing more than security robots, are you also doing like a warehouse robots and anything else?
No. So our focus is on the UGV. So specifically UGV applications.
Okay.
Yep.
Okay, well, here's a question for everybody. I'll stick with you, Phil. Are you guys currently doing any work in Japan or with Japanese companies here in the US? Go ahead, Phil.
Not currently, but you know, I was just talking to my business partner earlier, and we thought, you know, say for example, a Toyota, right? You know, in the port of Long Beach, you have thousands of vehicles coming into the port. Well, those assets can be managed and protected, you know, from a security perspective as a use case for, you know, to do that with the autonomous robots, right? Because they can see infrared at night. They have, you know, human facial recognition detection and threat recognition, and it's all in real time. You know, if you think about like a high sophisticated security fence, that's what the autonomous robot can do. It's actually have a fence in a restricted area, but the cameras are mobile out in the field, you know, and, you know, the robots can travel. You know, we have customers in overseas, like, you know, in Dubai, you know, they're protecting 25 square miles of assets and property. So to answer your question, I'm going to defer that back to SMP, but we are doing business overseas in different, you know, APAC, APJ, EMEA markets. But US, we're just really starting to develop and take things to the next level.
Sanjay, would you like to discuss that? I know you have the investment from Toyota, but you want to just, if you're able to share any of that information?
So without going into the details of the investment itself, our investor base as well as our customer base is very international. Includes both Japan, Europe, and the US. What was the specific question you were thinking of, Kevin?
Well, basically the question from the audience was, do you have business in Japan or with Japanese customers here in North America? So
yes,
I know you don't have the Japan office yet, I don't think, correct? But
that's correct. We do not have an office in Japan. Our investor base kind of gives you a clue as to who our customers could be. We also have partners. Notable among them would be contributors and co-founders of the Open Source Autoware Foundation, which is Tier 4. Tier 4 is a company headquartered in Japan, and they've contributed a lot towards open source autonomous driving software. And they're one of the partners that we work with in Japan, and we are both of us are continuing more contributions to there. But in terms of commercial customers, we would love to engage with more Japanese customers, both on robotics as well as autonomous driving type of applications, both on-road and off-road.
great. Luke, I think you may have answered this in the question box, but do you want to kind of discuss that for Ready?
Yeah, so we've got systems deployed at Japanese companies located here in the US at many of their facilities. And in addition to that, we also work very closely with the robot manufacturers that are in Japan. We have partnerships with a couple of them already. We're developing more partnerships. And while we don't have a location in Japan, but we see that as a market that itself is going to deploy more automation. We think it'd be a great opportunity to, from the relationships we get here to find business there and expand.
And this question, it could be for Luke or Kel. What kind of new tech skills are needed for workers on the factory floor, the robot operators?
So the beauty with our software is that we've made the interface so simple that really anyone that has skills that kind of pre-exist within a manufacturing environment will be able to control a robot. And we demonstrated this with a class that Kel gave down in Kentucky that was to a class of CNC machinists that many of them had been coal miners and they'd lost their jobs. And this program is to reskill them. They learned CNC machining over a period of 4 months. And then we had a course that lasted 3 weeks. And instead of just being a robot programming class, the class was about how do they automate the job that they just learned how to do. So they learned how to operate CNC machines. And in the course, in the first couple of days, they're moving the robot. And then the rest of the course, they're learning about what are all the other things that you need to think about when you do automation. How do you pick up parts? How do you put them in the machine? And also the operational concepts of how do you run a machine overnight? How do you monitor it? How do you plan for enough parts to come to the system, enough parts to come out of the system? So by having this visual flowchart environment, workers that are already skilled in other tools were able to use the robot as a tool. And that's why we have the slide in the deck is we don't want to train just robot programmers. We want anyone in the factory to be able to use a robot to leverage the skills and knowledge that they have. And we think that's really the transformational aspect of our company is that it's not these low-level robot skills anymore. It's just a tool and it's easy enough that anybody can use it.
Yeah, that's very much our vision, is that the robot should be the simplest part of the manufacturing equation in terms of the learning, and the rest of that time and upskilling should be spent on learning how to put those systems to work to do these complex tasks. Just like I can do amazingly complex things with my computer very easily, but I don't spend my time learning how to use the tool. I learn how to do the application and actually do what creates value with that tool.
Just a high level question that you might often hear. What would you say to those that are saying that robots are stealing jobs from workers? Kel?
Well, there's plenty, and Kel can expand as well, but
Yeah.
there's plenty of studies that show that there's more jobs in automation. It was a story I like to tell was about ice production. There used to be a lot of people producing ice. Well, we invented a refrigerator, and there's way more people in the refrigeration business, manufacturing, service, and also more people can now have ice. So it's never a zero-sum game, right? As we make things more efficient, we're going to have more things that improve the quality of life for everyone around the globe. So if we think and constrain our thinking to, yes, this person is being replaced with moving parts in a machine, but the fact is that mind of that person is now going to generate innovation ideas elsewhere. And that's been applied to every area of innovation. When cars replaced horses, now we have way more cars. So that's just going to be a continuous theme. And there's plenty of studies that show that that's not the fact, but it's a great question to ask.
Yeah, and just tactically, there's 2.5 million unfilled jobs in the United States in manufacturing right now, right? The skills gaps means you can't. There's no one coming into manufacturing, right? The baby boomers, people are retiring, they're leaving manufacturing, right? Jobs are not in jeopardy; they're in jeopardy of not being filled, and that's where automation can really help by not only putting robotic workers in those jobs, but then also, as I said, allowing the people who are immensely valuable with 30 years of experience at making this incredible component, that have all of that knowledge, that are being underutilized, and the automation allows them to be much more highly utilized for what they're good at, what they're experienced at, what they're valuable for.
Switching back over to autonomous systems, I just wanted to talk to Sanjay and Phil again about any type of regulatory challenges or hurdles that they might be facing. I know it might not be directly, but how are any type of regulatory challenges kind of slowing their growth or the growth of the industry in general?
You're correct that these are issues that our customers deal with more than us directly, but public perception and regulation are all needed to align well before we have autonomous systems running on the road in the form of self-driving cars. But you can see that in many countries these are already well on their way. Both specifically US, Europe, and Japan. These are and China are places where we're seeing this all the time. So we think it will be slow and there will be setbacks, but that's one of the reasons why we are focusing on safety. Because that is, I think, one of the ways in which we will help the public perception that an autonomous system can and should be as safe or better in terms of its safety record than a human driver. And I think that is where our focus is, and I think the automotive industry also is. Not every company is that way. There are some probably that will move faster than the others, and we will also explore the constraints of the whole regulatory system around it. But I have no doubt that will eventually, we will find, like in every other case before it, a way in which we will harness the productivity gains from autonomy while minimizing the sort of the cost we have to pay for this kind of new technology, improving the overall efficiency, while maybe there are cases that we will still have to handle in more manual ways.
Phil, I know your robots are not necessarily out on the open road, but are there any type of regulatory challenges you guys are facing?
Not specific regulatory. You know, they're compliant with all, you know, FCC and you know, that type of certification, ISO certifications, but you know, being able to be on certain data center security, right? So they're certified in that, you know, with that compliance. But you know, our model is, you know, they are around people, right? But there is no real compliance issues. You know, most of the time it's on a customer site, and we comply by, you know, their regulations and whatever their rules are. And you know, the robots have advanced navigation and obstacle avoidance. They're really safe. You know, I'm not gonna, you know, talk too much about competition, but the SMP does a great job of being able to navigate and use artificial intelligence to, you know, avoid situations. And I'll kind of leave it at that. But yeah, you know, some of the press has shown, you know, other robots doing things that are probably, you know, compromising. But I think from safety and security, the SMP is by far, you know, advanced in technology and by far, you know, a great solution. You know, the SMP has a lunar program, right? So these robots are, you know, lunar ready, you know, 15 years ahead in technology and advancement of most of the other autonomous robots we're seeing here in the market.
Thank you. We don't have too many more questions coming in here, so I wanted to kind of give an opportunity to you guys to give a quick closing remark, if you'd like. Just if you want to start with Ready Robotics.
Sure. So want to thank everyone for taking the time this afternoon for us to present our solution. We're, like I said, very interested in expanding within Japanese companies in the US or the Japanese market itself. So thank you very much. It's been our pleasure.
Yeah, it's been an absolute pleasure and honor to be able to talk with all of you today.
Thanks, Sanjay.
Yes, thank you, Kevin, and thank you, Jetro, and thank you for the audience for listening to our presentations. For companies in Japan specifically that are interested in learning more about us or about the open source, you know, please feel free to contact us. You know, just to summarize, you know, Apex AI is a company that makes the commercial version of open source software, and we would love to make connections and contribute in different ways to the community, and while also, you know, enabling the next generation of autonomous vehicles and robots. So looking forward to that.
Yeah, and I just echo the acknowledgement of Jetro and Kevin and Matt and team putting this all together. It was it was our first time participating, but we definitely be interested in doing this again. And I think our information will be shared with the audience. So if anybody has anything they have, any opportunities, you know, by all means, get in touch with us, and then we'll help answer questions and kind of move forward with you know, even any kind of proof of concept.
Thank you so much. Well, I'd like to thank all of our speakers today for taking valuable time out of your schedules to give presentations to our attendees. I'd like to thank all the attendees who have joined our event today and who have stuck with us through the panel session here. I know your time is valuable as well. Please keep an eye out for the video to be uploaded probably by Monday US time, Tuesday Japan time, if you're interested in watching on demand. I'd like to thank my colleagues, Akira, Matt, and from our other offices who have supported this event. Thank you so much. Noriko Rogers, our interpreter, thank you so much. So we look forward to seeing you possibly next month or December for our next event. Thank you again for joining our Jconnect webinar, and we look forward to seeing you again.